5.6 day 1, we're looking at inverse of a function. Now, because inverse functions interchange the input and output values of the original function, the domain and range are also interchanged. So the biggest thing that I want you to notice on here is that the x values here change to the y values in our inverse function, and then the y values in our original function become the x values in the inverse function. So the graph of an inverse function is a reflection of the graph of the original function, and it's reflected over the line y equals x. So y equals x is this line here. So if we put a mirror here, they are reflected across that line. Now, to find the inverse function algebraically, which we'll do in a minute, we're going to switch the roles of x and y, and then we're going to solve for y. So let's try it. So finding the inverse of a linear function. So we're focusing on linear. So here's our function f of x equals 3x minus 1. And so what we want to do, the very first step is you set y equal to f of x. That is always first. So therefore, this becomes y equals 3x minus 1. The next thing is to switch the roles of x and y. So just switch them. So change the y, change the x. So this becomes x equals 3 times y and then minus 1. The next step is you solve for y. So we add 1 to both sides and we get x plus 1 equals 3y. Now to isolate that y, we want to divide by 3. So we get y equals x plus 1 over 3. We could rewrite that. So remember, we can just split the fraction. Y equals x over 3 plus 1 over 3. And then let's rewrite this one here so it looks like slope. So y equals 1 over 3 times x plus a third. So you can either leave it here or here. Now you may want to put it in this form because when you graph, it's a little nicer to see the slope. So now the last thing you need to do is write the inverse of f as g of x. So that's how you show you have an inverse. So we have f of x, which is our original, then you have to write g of x, and this is 1/3 x plus 1/3. Okay, so you can't leave it as y or you will not get full credit. You need to write it as g of x to show that it's an inverse. Sometimes you'll see inverse written as f inverse of x. So that's sometimes another way you'll see it, but in our textbook and everything we'll focus on in this class, it'll always be g of x. So let's try this example together. Find the inverse of the function, then graph the function and its inverse. So the very first step, like we had up here, so I'll show it, set y equal to f of x. So this is y equals 2x. The next thing is to switch the roles of x and y. So just switch them. X equals 2 times y. Then we want to solve for y, so isolate that y, so divide by 2. So you get y equals x over 2, or let's write it in a different form. Y equals 1/2 x. And the very last thing, let's make it g of x equals 1/2 of x. So this is our inverse function. So now let's graph both. So let's graph f of x equals 2x. And so this is y equals 2x. Think about y equals mx plus b. B represents your y-intercept, and m is your slope. And then so remember that's rise over 1. So let's identify our slope for this equation. Slope is 2 over 1, and the y-intercept, b, is 0. There's nothing here. So what that means is we start at 0, 0, and then we use a slope of 2, 1. So positive 2 means up, positive 1 means right. So up 2, right 1, up 2, right 1. And just as a reminder, you could always go the other direction. So in order to make it still positive, you can say slope is -2, -1, because negative over negative is a positive. So therefore, from the origin, you can go down to left 1, down to left 1, and so it makes that line. So this is our f of x. And that's f of x equals 2x. So it's good to, number 1, label it, and number 2, make sure that you extend the line all the way through the coordinate plane, and then draw as many dots that will fit on the graph. Now let's do our inverse. So again, our y-intercept, there's no y-intercept, it's 0, so we start at 0. Our slope in this case, you can think of it as 1 over 2 or -1 over -2. Those both equal the same thing. So we start the y-intercept of 0, you go up 1, right 2, so up is positive, right is positive, up is positive, right is positive. Or you can go negative, right? Negative 1 is down 1, negative 2 is left 2. Down 1, left 2. So here is our graph. Now just to show you, we could say that it is reflected over that line, y equals x. So I want you to go ahead and try number 6. So be careful when you're distributing. So you will have to distribute there. So see if you can get the answer on that one. And then also try number 5 as well. Now number 5, just to tell you, number 5 is a special case. Okay, number 5 is special case. Number 6 is good. So do number 6, see if you can graph that line. So trying this out, number 6. First, you set f of x equal to y, so y equals 1/3 x minus 2. Then you switch the roles of x and y, so just switch it, x and y, here. Then you solve for y, so add 2 to both sides, so you get x plus 2 equals 1/3 y. Then, in order to get rid of the fraction, you multiply both sides by 3. So then that gets rid of the 1/3, so it's y on the right side. And here, this is 3, and you distribute it to both the front and the back. So it's 3x plus 6 equals y, or g of x equals 3x plus 6. So then, of course, our line here, so I graphed it. This is g of x here, and then this is our f of x. So g of x, you start at positive 6 here, and then you go up 3, right 1, or down 3, left 1, down 3, left 1. On the pink line, you start at negative 2, and your slope is up 1, right 3, up 1, right 3, or down 1, left 3, down 1, left 3. Okay, just again using the y-intercept, and then using the slope to find more points. Now, number 5 was a special case. So you set f of x equal to y, and then you switch the roles of x and y. You solve for y, and notice you get negative x plus 1 equals y. G of x equals negative x plus 1. Now notice that is the same exact line as the original, so there is no inverse of this function.